Look at this following diagram. Given 2 points A, x1, y1 and B, x2, y2 joined together, forming a line AB. Then the gradient of line AB is defined as m equals y2 minus y1 over x2 minus x1 equals tangent theta. Theta is the angle formed by the horizontal line parallel to the x-axis and line AB. The equation of the line AB can be expressed as follows: y minus y1 equals m times x minus x1, or y equals mx plus c, or ax plus by plus c equals 0. Example 1. The vertices of equilateral PQRS are P, -4, -3, Q, 3, -2, R, 5, 1, and S, -2, 0. Show that PQRS is a parallelogram. Solution. Show in mathematics does not mean to sketch or to draw. In mathematics, we have to write or to explain the evidence that supports the statement. So how to show that PQRS is a parallelogram? Remember that if both pairs of opposite sides of a quadrilateral are parallel, then it's a parallelogram. Using the points in the question, now we are having the gradient of each side of the quadrilateral. The gradient of PQ equals 1 over 7, the gradient of SR equals 1 over 7, the gradient of QR equals 3 over 2, and the gradient of PS equals 3 over 2. So based on this calculation, we know that the gradient of PQ and the gradient of SR are equal, and the gradient of QR equals the gradient of PS. From here we know that PQ is parallel to SR and QR is parallel to PS. Then we have the conclusion ABCD is a parallelogram. If two lines are parallel each other, say L1 is parallel to L2, then the gradient of L1 and the gradient of L2 will be equal. M1 equals M2. Example 2. Find the equation of the straight line L2 which passes through the point 8, 3, 4 and is parallel to the line L1. 2x plus 5y minus 10 equals 0. Solution. Based on the question, we have the first line 2x plus 5y minus 10 equals 0, and also based on the question, L1 is parallel to L2, therefore the gradient of L2 equals the gradient of L1. Based on the question, we have this following equation, and by a slight modification we have that y equals -2 over 5x plus 2. Using the equation of line in the form of y equals mx plus c, we know that then the gradient of L2 equals -2 over 5. The equation of the straight line L2 which passes through point 3, 4 is y minus y1 equals m times x minus x1. Here 3 is x1 and 4 is y1, and the value of m is the value of the gradient of L2 equals -2 over 5. By the substitution we have this following, and by the simplification the equation of the straight line L2 is 2x plus 5y minus 26 equals 0. If the line L1 makes the angle 90 degrees to the line L2, then we can say that L1 and L2 are perpendicular each other. If they are perpendicular each other, then the multiplication of their gradient equals -1. M1 times M2 equals -1. Example 3. The diagram shows two perpendicular lines PQ and QR. The coordinates of R are 5, 3. The equation of PQ is 2x minus 3y plus 12 equals 0, and P is a point on the y-axis. Find the coordinates of P and the equation of RQ. Solution. Look at this following diagram. Based on the question, PQ is 2x minus 3y plus 12 equals 0. Based on the diagram, P is a point on the y-axis, or simply as y-intercept. Therefore, the value x equals 0. By substituting the value of x into the equation, we have this following. From here we know that the value of y equals 4. Therefore, the point of the y-intercept is P equals 0, 4. The line PQ is 2x minus 3y plus 12 equals 0. Now we are going to find the gradient of PQ, which is from 3y equals 2x plus 12 and y equals 2 over 3x plus 4. Therefore, the gradient of PQ equals 2 over 3. Since line PQ and line RQ are perpendicular each other, MPQ times MRQ equals -1. Therefore, by substituting the value of MPQ, we know that 2 over 3 times MRQ equals -1. The gradient of RQ equals -3 over 2. Now, the equation of line RQ is written as y minus y1 equals m times x minus x1, which the gradient is mRQ equals -3 over 2, which passes through the point 5, 3. Here we know that x1 equals 5 and y1 equals 3. By substituting these values to the equation, we will have y minus 3 equals negative 3 over 2 times x minus 5, and simplifying this will give the result 3x plus 2y minus 21 equals 0. For the line segment joining A, x1, y1 and B, x2, y2, the midpoint M of AB is x1 plus x2 over 2, y1 plus y2 over 2. Example 4. Three vertices of a parallelogram PQRS are key 4, -1, R, 7, 4 and S, 0, 3. Find the coordinates of the midpoint M of the diagonal QS and the fourth vertex of P. Solution. Midpoint M of the diagonal QS. Firstly, we put all the points in the Cartesian diagram. Here is the point Q, point R and point S. We visualize the diagonal QS and the midpoint of M. We will use the formula of midpoint M equals x1 plus x2 over 2, y1 plus y2 over 2. From point Q and S, we have this following value of x1, y1, x2 and y2. Substituting the values of x1, y1, x2, y2 into the formula, we obtain M equals 4 plus 0 over 2, -1 plus 3 over 2. Simplifying this will give M equals 2, 1. We can verify this point x equals 2, y equals 1. Part B. Fourth vertex of PQRS. In a parallelogram, we know that midpoint of PR equals midpoint of QS. Let's say point P is x, y and point R 7, 4 from the question. x1 is x, y1 is y. x2 equals 7, y2 equals 4. And using the midpoint formula, we have this following equation. From the midpoint of PR, x plus 7 over 2, y plus 4 over 2 equals 2, 1 from the midpoint of QS. From here, we know that x plus 7 over 2 equals 2. Therefore, x equals -3. From y plus 4 over 2 equals 1, y equals -2. Therefore, the point P equals -3, -2. Here is the sketch of PQRS. P equals -3, -2. Therefore, this is a parallelogram. Let's find the area of rectilinear figures. We start from the area of triangle. Look at this following diagram of the triangle ABC given their coordinates A, x1, y1, B, x2, y2, C, x3, y3. If we rearrange the points of A, B, and C in anti-clockwise direction, then the area of the triangle ABC is defined as follows: 1 over 2, x1, y1, x2, y2, x3, y3, x1, y1. Because we start from point A, x1, y1, and then we go anti-clockwise to point B, x2, y2, and go anti-clockwise once again to point C, x3, y3, and then go back to point A, then it is a closed plane to point x1, y1. This is the expansion of the formula. Example 5. Find the area of triangle ABC whose vertices are A, -3, 5, B, 1, -4, and C, 4, 2. Solution. Firstly, sketch the diagram of the triangle in Cartesian coordinate system. Here is the triangle ABC. If we put the coordinates of the points in anti-clockwise direction, we start from point A and it goes to point B. From point B to point C and return back to point A. Point A as the starting point. x1, y1 is from point A, x2, y2 is from point B, and x3, y3 from point C. The area of the triangle ABC is as follows. Substituting the values of x1, y1, x2, y2, x3, y3 will give this following result. To calculate the area of triangle ABC, then we have to multiply diagonally. Starting from -3 times -4, 1 times 2, 4 times 5. The results are shown by the red numbers, and 1 times 5, 4 times -4, -3 times 2. The results are shown by the blue numbers, equals half times the sum of the red numbers subtracted by the sum of blue numbers, equals half times 34 minus -17, equals half of 51. Therefore, the area of the triangle ABC equals 25.5 square units. The area of quadrilateral ABCD given the coordinates of the points x1, y1, x2, y2, x3, y3, x4, y4 in anticlockwise direction is given by this following formula. We start from point x1, y1 and go to x2, y2, x3, y3, x4, y4 and return back to x1, y1. Remember, in anticlockwise direction. In general, if the vertices of n-sided polygon taken in the anticlockwise direction are x1, y1, x2, y2 until xn, yn, then the area of the polygon is defined as follows: equals 1/2 times x1, y1, x2, y2 until xn, yn and return back to x1, y1. Example 6. The vertices of hexagon are 5, 2, -1, -3, 2, 6, 3, -2, -4, 0, and -3, 2. Find the area of the hexagon. Solution. Firstly, we have to sketch the hexagon in coordinate system. Here is the hexagon. We can choose any point as the starting point in the formula of the area. I choose 5, 2. In anticlockwise direction, then the order after starting point 5, 2 is 2, 6, -3, 2, -4, 0, -1, -3, 3, -2, and back to 5, 2. Therefore, the order will be like this. And as the result, we have x1, y1 until x6, y6 in order. The area of the hexagon is 1/2 times x1, y1, x2, y2 until x6, y6 and return back to x1, y1. Substituting the values will be like this. We multiply as usual 5 times 6, 2 times 2, -3 times 0, -4 times -3, -1 times -2, 3 times 2. And results are shown by the red numbers. And then the other diagonals, 2 times 2, -3 times 6, -4 times 2, -1 times 0, 3 times -3, 5 times -2, and the results shown by the blue numbers equals to the half times the sum of the red numbers subtracted by the sum of the blue numbers. So the area equals 47.5 square units. Stay at home, tetap semangat!